Welcome everybody. This is a video tutorial on a problem solution related to rotational kinetic energy, work and multi-particle system. So here is our question. A wheel is mounted on a stationary axle which is nearly frictionless so that the wheel turns freely. The wheel has an inner ring with a mass 5 kg and a radius 10 cm and an outer ring with mass 2 kg and radius 25 cm. The spokes have negligible mass. A string with negligible mass is wrapped around the outer ring and you pull on it, like the question says for you. It can be me or you, anybody, and you pull on it, increasing the rotational speed of the wheel. During the time that the wheel's rotation changes from 4 revolutions per second to 7 revolutions per second, how much work do you do? So this is our free body diagram of the wheel. The string is connected to the outer circle of the wheel, as you can see, and there is an inner circle, and the inner circle is 10 cm in the radius and its weight is 5 kg, and the outer circle is 25 cm in radius and its weight is 2 kg. So as far as the solution goes, first we need to determine what are our systems. The systems in this question are the wheel and the string that are doing the work, and our surroundings are our hand, of course, is pulling on the string, and there's the axle and the earth. So the first principle that we're going to use in this question is the energy principle, and energy principle says final energy is equals to initial energy plus work done by that energy. Since we are dealing with rotational problems, we have to use the inertia and omega, which is equivalent to velocity in a linear movement. And for final energy, we have half times inertia times omega square is equal to half I times omega initial square plus work done. And solving that, we get work done equals to half I times omega final square minus omega initial square. So we're going to use this formula later on to get our work. Now, the moment of inertia is a composite object. Of a composite object is the sum of the movement of inertia of the individual process. So if you're finding the moment of inertia of a whole big body, we need to add individual pieces of each atom, and to do that we have to add I is equals to m times r squared plus so on for every atom of the inner wheel, and similarly for the outer. And generalizing that equation, we get I is equal to I inner plus I outer. Moving on, from the formula that we derive while we first calculate the inertia for any shaped object, we are given that for a ring the moment of inertia is mr square, where all the atoms are at the same perpendicular distance r from the center. Hence the moment of inertia of this wheel is also equal to I equals to m times, that actually is a multiply sign between m inner and r inner. That's a mistake there, I'm sorry about that. It's m inner times r inner square, and since we have two wheels we have to add both of them, so we also have m outer, and sorry for that mistake again, that's multiplication sign right there, and m outer times r outer square. Solving this, we get 0.175 kg per meter square as our inertia for the wheel. Now we need to convert the revolutions per second that the question had given us into radians so that we could use them later on while we calculate work. So to do that, all we have to do is multiply the revolution per second times 2 pi, and then we get them in the radian per second. Now for the final process, we need to find the work done. So we need to find which of the surrounding did the work. Was it the hand, the axle, or the earth? Now since we were given at the beginning of the question that the wheel and the axle are frictionless, so the action doesn't do any work. And then we also noticed that throughout the period of solving this problem, the center of the mass of the wheel doesn't change, hence earth has done no work too. And then we had derived the work done before, which is equal to W equals to I times the half I times omega final minus omega initial square Now, that actually is the work done by us or you or whoever pull on the string. So W, that is work done, is equal to half times inertia times omega final square minus omega initial square, and then we have already calculated the total inertia of the wheel, that is 0.175, and then we have the omega final in terms of radian per second, that is 44, minus the omega initial, that is 25.1 in radian per second, and solving that we get the value 114 joule. Thank you.